Sedimentary structures refers to the layering of sedimentary rocks, to the surface features on those layers, or for the arrangement of grains within those layers. These structures are really important because it tells us a whole lot about the environment in which the rock was deposited. So the most common type is just layers. Alright, so if you have a single layer with a recognizable top and bottom, this is called a bed. And if you put a whole bunch of beds together, it's called strata. So strata means layers. It's actually from a Latin word that means pavement. Right, but these different beds and different strata form due to changes in the climate, water, depth, current velocity, or sediment source. So every time that changes, it tells us there's been a slight change in the environment. Some other structures include ripple marks. You've probably seen these before, like at the beach or along a river bottom. So ripple marks are small ridges that form on a bed surface. These preserve the direction of the flow of water or wind sometimes. So it tells you which direction it's going. So if you look at, these are current ripples of sediment. The picture on the right are preserved ripple marks in sandstone. So if we look, you can see it goes up and then really sharp down and goes up and really sharp down. So the left side is actually much steeper than the right side. What this tells us is that the flow of water was going from the right side of the image to the left. So you can actually track how water flow changes over time by looking at how the ripple marks change. Crossbeds are distinct internal laminations. They're inclined at an angle to the main layer. These form due to a current of moving wind or water. And oftentimes you can tell whether it was wind or water by the sheer size of them. In the picture are crossbeds in Zion National Park in the Navajo sandstone. These are huge, big, swoopy shapes. So these are going to be formed in sand dunes, really big sand dunes. So in the diagram on the left here, it shows you the wind's blowing from the left to the right. Sand doesn't get picked up and just carried by wind. It actually does what's called saltating. That means to jump. So a little sand grain gets blown and it hops its way up the sand dune face here, and then when it gets over here it slides down. That's why it's called the slip face. So this steep slip face is what's actually preserved as the crossbed. So if you see here on the picture, that is an old slip face. So the dunes slip face was over here, and then over time the dune actually migrated further and further to the right as the wind blew it across. So we can also use these to look at big major wind patterns over an area. Here's an example of some other crossbeds. This is actually in Sandy Canyon, just outside of Flagstaff. You have some beautiful crossbeds here. These are also really easy to recognize, and it's almost always sandstone that forms this, just because that's what you get in big sand dunes, is the sand-sized sediment. Now, graded beds are beds in which the grain side varies from really coarse at the bottom to really fine at the top. Now, these are formed due to underwater landslides. These are called turbidites. So you can see, here's a turbidite, also known as a turbidity current or a turbidity flow. So what happens is when you're on the continental shelf, there's a big drop-off off of the side of the granitic material of the continental crust down into that deep ocean of the oceanic crust. That big steep drop-off is a great place to get landslides. And so all that terrigenous sediment that builds up on this continental shelf falls off and slides down to the deep ocean, and you get these beautiful graded beds, which is pretty neat. Now, there's a type of mineral known as a clay mineral. These are a result of the weathering of silicate minerals through hydrolysis. If you remember, that created a clay mineral. Now, when these clay minerals get wet, they swell up, and when they dry out, they shrink back down. And that swelling and shrinking creates mud that cracks as it dries. So you get, the mud dries and cracks into polygonal plates that are separated by these gaps, these mud cracks. So over here, these are kind of older ones preserved. On the right, these are actually from a mountain in Tempe, right on the ASU campus. And what has happened here is there was actually mud cracks on the top of a bed, and then this bed was laid down on top of it, and you had more mud fill in where those cracks were. And so it's kind of a cast of those mud cracks, and that's pretty common to see. One of my favorite types of sedimentary structures is a fossil. So everybody loves dinosaurs, and that's only one type of fossil. It's the bony parts that are left over. That's a picture of Sue from the Field Museum in Chicago. She's a beautiful, crazy history to how she got there. On the top, middle on the top, you have petrified wood from the Triassic Chinle Formation in northern Arizona. On the right, you have a brachiopod, which is a marine organism. It's actually been replaced by pyrite, which is very cool. Right below it is a cephalopod called an ammonite. So this is related to like squid and the octopus and cuttlefish. It actually is probably most similar to the chambered nautilus. And that dude is for scale. These were the scourge of the Cretaceous ocean. These were pretty mighty predators at that point. In the middle there, on the bottom, is actually pollen. Pollen is preserved really surprisingly easy. And so you can tell what all kind of plants were living in an area, even if you don't have any impressions of plants left over. And finally, this little weird one that looks like something out of the movie Signs, or an alien movie. This is actually where a jellyfish-like animal sat down on the bottom of the ocean, and you can see the outline of his tentacles. So this one is a little bit different than all the rest of them, right? Because everything else is actually like parts of the animal, but this is just a trace that the animal leaves behind. So it's called a trace fossil. Here's some other examples. Remember that picture of the limestone in Texas that I showed you early on when we were talking about beds? This is that same limestone, and in it you have all sorts of dinosaur trackways. This is from the Glenrose limestone. It's actually about 30 minutes from where I grew up. There's an area here in the bed of the Paluxy River called the dance floor because there's so many footprints, but it's actually kind of cool because there's like this big lumbering plant-eating dinosaur, and kind of in and out of the trackways in between his feet are these little meat eaters that are following him, which is really cool. But these are really famous trackways. There's actually a set of these that are on display at the Natural History Museum in New York City. Actually carried them all the way up there. In the middle, these are dinosaur trackways from Tuba City. So there's your Arizona tracks. So these are just off of, just a little bit outside of Tuba City. It's on reservation. These are in the Moenkopi Formation. And here in the Grand Canyon, this is in the Coconina Sandstone. You look, you can see like 3 little dots, and then 3 little dots, and then 3 little dots, and then 3 little dots. That's either a spider or a scorpion trackway. And what you can't see is those little dots are like 4 inches across. This thing was enormous and terrifying. The good news is they've been dead for a long time because that's a Permian sandstone, so it's over 250 million years old. Down here, this kind of wicked looking shape here, this is actually a worm burrow. Over on the left, this is a trace fossil called Cruziana. Trace fossils, so trackways have their own genus and species name. So it doesn't always actually go along with the name of the critter that left it behind. But this particular one is actually created by a trilobite, which was a little, almost like an underwater doodle bug, little roly-poly that lived on the bottom of the ocean floor. And then everybody's favorite in the middle, that's exactly what it looks like. That is what's called a coprolite. It's fossilized poop. Alright, so hopefully you got an idea of some of the structures we can find in sedimentary rocks and see how they tell us a lot about the environment that rock formed in.